For this example, we're given coordinates for triangle ABC, and we're trying to find x for coordinate B. So we're trying to find the x value that will make triangle ABC a right triangle. So the very first thing I want to do is I want to start with plotting what I'm given. So we have A, which is 5, 6. So 2, 4, 5, and then up 6. So here's A. C is 2, -3. And B, we know the y value is 5, so I know that the y value, 1, 2, 3, 4, 5, has to be somewhere on this yellow line. So basically, I have to figure out what x value, or where do I place B on this line so that I can connect it and make a right triangle out of AC. So as soon as I look at AC, so if I look at this segment here, if I place B somewhere over in this area, it looks like I can make a right angle at A, and then that means BC would be the hypotenuse. So what I'm going to do is I'm going to find the slope of AC, and then I'm going to flip and negate that slope and solve for the coordinate of x for B. It's basically what I need to do. So I'm going to start with finding the slope of AC. So remember your slope formula, y2 minus y1 over x2 minus x1. You could also count here, but I already did an example where I was counting. So for this one, I want to do the slope formula. So to find the slope of AC, we're going to subtract the y values. So it'll be -3 minus 6. And then subtract the x values. So 2 minus 5. So you're going to get -9 over -3. Divide those out, you're going to get +3. So that means the slope of this line right here is +3. So if I want to make angle A a right angle, it means the slope of AB would have to be flip and negated. So if you flip and negate this, that's going to be how you're going to create that right angle. So flip and negate, it's going to become -1/3. And that's what I'm going to set the slope of AB equal to. So I know that the slope of AB must be -1/3 in order for this to actually be a right angle. So I'm going to go ahead and I'm going to set up the slope of AB using the coordinates that I have. So the slope of AB, so we're going to subtract the y values. So AB subtract, so 5 minus 6. And then on the bottom, it's going to be subtract the x values. So I'm just going to use x minus 5. So when I do this, I get -1 over x minus 5. Now I know that these two things here have to be equal. The slope of AB has to equal -1/3. So I'm going to set those equal so that I can solve for x. So -1 over x minus 5 has to equal -1/3 in order for this to be a perpendicular, or in order for these two lines to be perpendicular. So now I can cross multiply, so I end up with -1 times x minus 5. Make sure x minus 5 goes in parentheses, equals -3. You could cancel out the negatives here, but I'll just distribute it. So -x plus 5 equals -3. Subtract 5 from both sides. So we get -x equals -8. Divide both sides by -1, you get x equals 8. So that tells me that the coordinate of the x coordinate of B is going to be 8. So up top here, instead of x, I know that this has to be 8. So then the second part of this question says to justify why triangle ABC is a right triangle. So you could just write, I know that it has to be a right triangle because the slopes are negative reciprocals of each other. And that would be enough. The slopes of AC and AB are negative reciprocals, which means the lines are perpendicular, which means that you have a right angle. But I'm going to go ahead and I'm going to use the Pythagorean theorem because I want to show you that method of how to show it's a right triangle. So I'm going to go ahead and plot point B here. So B is going to be over at 8. So 2, 4, 6, 8, up at 5. So here's B. So if I want to show that this is a right triangle, it means I'm going to use Pythagorean theorem to show that this angle is a right angle. So I'm going to find the distances of each of these sides. So let me go ahead and do that. So I'm going to find the distance of side AB. So this is kind of like part 2 to the question. This is the justification. So I'm going to use the distance formula. So that's going to be your change in x's squared plus your change in y squared. So the distance of side AB, I'm just going to plug in the x values here. So subtract the two x values. Well, we know the new x value of b is 8, so it's going to be 8 minus 5. Then I'm going to plug in the y values and then work inside of parentheses. So we end up with 3 and then negative 1. Square each of those, so you get 9 plus 1, so we get the square root of 10. Then we're going to move on to side BC. So subtracting the x value, so 2 minus 8 plus negative 3 minus 5 equals, this will be negative 6 squared, this will be negative 8 squared. Then when we square a negative, remember it becomes positive, so 36 plus 64. This gives us the square root of 100, which equals 10. So remember, I'm just getting the coordinates from up top there. And then the last distance formula, AC. So subtracting the x's from A and C, so it'll be 2 minus 5 squared plus negative 3 minus 6 squared. Combine the parentheses, so we get negative 3 squared plus negative 9 squared. So we get 9 plus 81, add those up, and we get the square root of 90. So if I go back up and label my triangle with my distances, side AB is square root of 10, side BC is 10, and then side AC is square root of 90. So now we want to see, do these numbers work in the Pythagorean theorem? Because if they do, then this really is a right triangle. So when you do this, remember that BC is the hypotenuse because it's the side across from the right angle, or that's the side that we need to use as the hypotenuse because it's the longest side. So that's what's going to go in for C. So now that we have our distances, we're going to check in the Pythagorean theorem. So if you plug in, A will be square root of 10, then square root of 90, and we're checking, so I'm going to put a question mark here, and the longest side is 10, so that's going in for the C value. We're going to simplify this, so if you square root, it's just going to be what's underneath it, so 10 square root is going to be 90. We want to see, does this equal 10 squared? Well, 10 squared is 100. 10 plus 90 gives me 100. So the numbers work in the Pythagorean theorem, so therefore triangle ABC is a right triangle because its side lengths satisfy the Pythagorean theorem. You could also say that it's a right triangle because the slopes are flipped and negated, so they form perpendicular lines, which means you have a right angle at angle A. That would also work, but like I said, I wanted to go a step further and kind of almost prove to you why it's a right triangle using a different method, just so you could see how to prove a right triangle as well.